No, not that. So, polynomials. What we're learning today is really just a whole bunch of rules that'll help it so that the goal is to be able to make a graph of an equation without doing any computation. Like not plugging into a calculator, not doing negative b over 2a, just what sort of patterns exist within an equation so you know what that graph would look like. Today and tomorrow we are sketching. When you hear the word sketch, how is a sketch different than a graph? It's not as accurate. It has the basic characteristics, but it's not as accurate. What we're going to add in is how do you change that sketch into a graph, but today we're just sketching. We're working with polynomials. The prefix poly means what? Many. So we're just looking at a polynomial means it has many parts. Two ways that you can write a polynomial. One is in standard form. So if it is in standard form, it's the same standard form as quadratics. It's not multiplied out. So in standard form, it would look like ax to the n plus bx to the n minus 1. So that n and n minus 1 just means you write your exponents down in order, and you just keep going until you hit your constant. So standard form is always just multiplied out. Factored form,
What was the n for?
the exponent. So n is your exponent.
No, but like after that.
N minus 1. And then just dot, dot, dot until you hit your constant. Factored form, if something is factored, what does it put inside of it?
Parentheses.
Parentheses. So factored form of polynomials is still the same thing. So all the way. So just factored form is in its parentheses. Standard form is not in its parentheses. You can classify polynomials. So classifying means like how do you give it a name? So you guys actually know some of these already. You can name a polynomial by its degree. What its degree is its highest exponent. So when you're talking about the degree of an equation, it means its highest exponent. If the degree is 0, so if the degree is 0, does it even have an exponent? No. Exponents go on variables when we talk about the degree. So if it has a degree of 0, it's just a constant. AKA, there's nothing. So if you just had a number, you guys know that thing at the end that doesn't have an x is a constant. If it has a degree of 1, then it's linear. Which you guys also know, y equals mx plus b. Does that x have an exponent on it? No, it's linear. What does a linear equation look like? A line. If it has a degree of 2, so if its highest exponent is 2, then it's a quadratic. What do quadratics look like? Parabolas. It's what we just got done working with. All of those were x squareds. They were all quadratics. If it has a degree of 3, anybody know what a x to the third power is called? Cubic. It's cubes. So if its highest exponent is a 3, it's cubic. 4 is quartic. So quartic, because how many quarts are in a gallon? 4. 5, what do you call a set of 5 babies? Quint, so this is quintic. So it's all these prefixes that you already know. If it's 6 or more, it doesn't have a name. You just say it's degree whatever. So if the degree is 7, you would just say degree 7. Doesn't have a name. The other way you can name it is by its number of terms. So number of terms just means how many pieces are added or subtracted together. So how many parts are there? If it has just one part, it's a monomial. What does the prefix mon mean? Mono? 1. If it has 2 pieces, it's a binomial. Bi means 2. If it has 3 pieces, what prefix means? Trinomial. So when we factored all those trinomials, because they all had 3 pieces, and yours says 4 plus, because yeah, anything more is just a polynomial of that many terms. So anything more than 3 doesn't have a name, it's just a many-pieced thing. So when you're asked to classify something, you're just looking at the degree and the number of terms that it has. First example on the left. what's its highest exponent?
4.
4. So if it has a highest exponent of 4, degree-wise, what would you call it? Quartic. A degree of 4 is quartic. And then how many pieces does it have? 3. So it's a quartic trinomial. On the next one, what's its highest degree? 5. So it's quintic. And then how many pieces? 2. So it's a binomial. Both of these are in standard form. How do you know they're in standard form? They don't have any parentheses. So standard form, just look for the highest one. Name. So that is classifying polynomials. In the whole grand scheme of things, this is like a pedal in the water. Doesn't matter. I don't know if pedals in water matter. I just made that up. Here it is where it actually starts. What we're going to be looking at is how do you see an equation and start to piece together what the graph would look like. So without actually graphing it, what kind of information do we know? So each of these boxes is one piece of information you can figure out. The first one has to do with the end behavior. What the end behavior is as the graph finishes out, like what are your tails doing? So as they go to infinity, positive and negative, are your tails going up, down, things like that. The end behavior is based on the degree. So the degree ends up being a huge thing for polynomials. What is its highest exponent? If you're looking for the degree in standard form, it's just the highest exponent. If you're looking for the degree in factored form, then you have to add up the exponents. Because factored form is what you get when you break it into its pieces. So if you want to find the whole thing again, you have to put it back together. So your end behavior has to do with if your degree is an even number or an odd number. So an even number means it's an even function, which means your tails go together. So if you look at these tails together. So in this case, they're both going up. In this case, they're both going down. If you look at the equations underneath them, what's your highest exponent? 4. Is 4 an even number? Yeah, so that's how you know they have to go together. On the next one, it's a 2. Again, 2 is an even number. So there's a difference of, like, clearly the tails are going together, but there's a difference on if they go up or if they go down. If you think back to quadratics, what kind of number has to be in front in order for your tails to go up? A positive number. So if you are going up and up, that means you have a positive leading coefficient. So whenever I write LC, leading coefficient, you're starting with a positive number. This rule you already know from quadratics. If you have a positive A term, it goes up. If you have a negative leading coefficient, then which way does it go? Down. So the even ones, those are the easier ones because both go up, both go down. When it's odd, that's where things get kind of weird, because if you have an odd degree, then your tails go separate. So as you can see there, instead of them both going up, you have one of each. This very first one, do you have a positive or a negative leading coefficient? Positive. So a positive leading coefficient means that your tail has to end going positive. It's the same rule as slope. So if you have a positive slope, doesn't your graph go up from left to right? Is this graph also going up from left to right? So it's the same rule as slope. Here, you have a negative leading coefficient, and you end down. So whatever your leading coefficient is, that's where your graph ends. Since your tails are going separate, if you're ending down, obviously the other one has to start up. So the degree tells you what your tails are doing. The leading coefficient tells you what direction they're going. This top one right here. Look at your tails. Are they going together or separate? Separate. So does this degree have to be an even or an odd number? Odd. Whatever that exponent is, we know it's odd. And then, do we start with a positive or a negative leading coefficient? Which way are we ending? We're ending down, so we have a negative leading coefficient. On this next one, our tails are both going up, so do we have an even or an odd degree? Even. Whenever they're together, they go even. And since they're both going up, what's our leading coefficient? Yeah, positive. Read the next one. I know the print is tiny. See if you can figure A, B, C, D. Which graph are they talking about with what they're describing? So if an even degree polynomial, so even degree means what do your tails have to be doing?
Positive.
Even means the same, together, they're going in the same direction, and a positive leading coefficient, so where do the tails have to be going? So A, B, C, D. C, positive, they're both going together. Even, they're both going up, so up, positive. Questions on the end behavior? The next thing we look at is the turn. So how many turns can a polynomial take? Since it's a polynomial, we're going to end up with stuff like this. So when I say a turn, how many times does this graph turn around? 1, 2, 3. It has 3 turns. So maximums and minimums are your turns. The turns are also based off of the degree. So n is your exponent. So a graph can have at most n minus 1 turn. So whatever the degree is, take away 1. That's the most amount of turns it can have. Or 2 less repeatedly from n minus 1. So in that first one on the left, what's the degree of it? 5. The degree of this is 5. So since the degree of it is 5, at most, how many turns could it take? 4. You just take away 1. So at most, that polynomial could turn 4 times. Take away 2, or it could turn 2 times. Take away 2 again, or it could turn 0 times. So knowing just that if you have a highest exponent of 5 and it can take 4, 2, or 0 turns, could this possibly be the graph for this? No, the turns don't match up. What else doesn't match up? What are these tails doing? Yeah, they're going together, but if this has a degree of 5, what would the tails have to be? Opposite. So we're looking at those connections between the equation and then what the graph would look like. This is what factored form looks like. So factored form, it has it broken up for you in pieces. It doesn't matter what's in the parentheses. It matters the exponent of it. So we have 1 of those parentheses, 1 of those parentheses, 2 of those. So to find the degree of this, you add up your exponents. So 1 plus 1 plus 2, 4. So if it has a degree of 4, at most, how many turns can it take? 3. Take away 1. At most, it can take away 3, or it can turn 3 times. Take away 2, or however, what's the other amount it could turn? 1. Can you take away 2 again? No. So you take away 1, and that's the most amount it can have, and then you just start taking away 2 until you can't take away 2 anymore. This one, how many turns did we say this guy has? 3. So go backwards through it. If you know it has 3 turns, what could its degree possibly be? She right with 4? Yes. So you can go the other way. Rather than taking away 1, you can add 1. Does a degree of 4 match the tails?
Yes.
Yeah, 4 is an even number. The tails are going together. So end behavior and terms are all based on the degree. The degree is the what? The exponent, the highest exponent. The other thing that we really look at is something you already know. It has to do with the factor theorem, which gives you zeros. So you guys are used to doing this. If something is in parentheses, you can find out what x equals. x plus 1 is a factor, what answer does it give us? Minus 1, because you just said it equal to 0. If x plus 3 is a factor, what answer does it give us? If x minus 2 is an answer, what answer does it give us? Positive 2. This was the first question on your test, and surprisingly, not a very good question on the whole. What are these? When you solve an equation and find out what x equals, what are these? X-intercepts. So when you solve from factored form, or when you solve from anything, it gives you the x-intercepts. It's called solving because you're finding out where x equals 0. It's called the roots because you're finding out where it hits the x-axis, the solutions, it all fits together. So that theorem, you guys already know, but now instead of just having 2 pieces, you can have lots of pieces. That theorem you can work through backwards. What if instead I said, well, the zeros are negative 2, 3, 5. Could you write me an equation in factored form? If negative 2 is a 0, what parenthesis did it come from? If 3 is a 0, what parenthesis did it come from? If 5 is a 0, what did it come from? A cubic polynomial. Cubic means what would your degree have to be? 3. If you add up these exponents, I have one of these, one of these, one of these, what does it equal? 3. Do you notice how many zeros did we start with? 3. The amount of zeros in the degree are connected. So you should see lots of like, well, 3, 3, 3. Yep, it all makes sense. The zeros are going to take a different look than what they did for quadratics. When we had it in quadratics, the 0 is just where it touched the x-axis. That 0 can happen in different ways. So the zeros come from multiplicities. So a 0 is where it touches the x-axis. The multiplicity tells you, okay, well, what does it actually do at that part? Multiplicities has what word in it? Multiples. It means your exponent. How many of these x minus 5s do we have? 2. So that has a multiplicity of 2. How many of these x plus 1s do we have? 3. So that has a multiplicity of 3. So when it says multiplicities, it just means what's your exponent on your factor. The multiplicities have whenever we talk about multiplicities, we're going to talk about how they affect the graph. So when you see a multiplicity of 1, what it means is it's going to cross at that point. So whenever you are seeing an assignment like, what is this multiplicity? I don't want you to say the multiplicity is a 1. I want you to say it crosses. Because rather than just say the number, tell me what it's doing on the graph. Because all of this has to come back from the graph. Graphically, what that means is it literally just like crosses through the point. It goes from below to above, just goes straight through. If it has a multiplicity of 2 or any even number, because this chart only goes up to 3, then it's going to bounce at that point. So if you bounce, it doesn't actually pass through. It's going to hit it and then bounce back up. So that's what a bounce looks like. Quadratics, you saw that when the vertex was the answer. The last one, a multiplicity of 3, means it's going to sway through that point. And the best way I can describe a sway is if my goal, like I'm walking to the computer, if I'm walking and then like sidestep but keep going, do I ever change direction? No, that sidestep is just it. So when you sway, what that means is you kind of just level off, but you keep going. You do touch the x-axis at that point, but you don't turn around, you don't go straight through, you sway through it. So the multiplicities tell you how it hits the x-axis. The number inside tells you where it hits. So finding the zeros. Whenever you find your zeros, it is assumed you will also state what their multiplicity is doing. So the first 0 is right there. If you just have a single x, where does this touch the x-axis? 0, because when you set it equal to 0, you get 0. What is the exponent on that x? It's a 1. If you don't see an exponent, assume it's a 1. So is it going to cross, bounce, or sway? Cross. So whenever you write your zeros underneath it, write what is it doing at that point. It's going to cross at that point. Your next 0, If x minus 5 is a factor, what 0 do you get? 5. What's its multiplicity? Natalie said balance. Is she right?
Yes.
Yes, a multiplicity of 2, an exponent of 2 means it's going to bounce at that point. The last one, where does it touch the x-axis? -1. Since it has a 3, what will it do at that point? Sway through. So we're building up what this graph is going to look like. You're going to use all of these pieces together. And when I say all the pieces, I mean go back to, like, what's the degree of this? What is the degree of this polynomial? 6. What's its leading coefficient? What kind of number does it start with? A negative. A leading coefficient, it doesn't matter what the number is, all that matters is it positive or is it negative? Your end behavior, so LC, leading coefficient, EB, end behavior. If your degree is 6, what are your tails doing? Together or separate? Together. 6 is an even number. Since it's negative, which way does it go? Down. Always draw pictures. I think, did any of you guys have Mr. Painter last year? Okay, I think he had you write words. Don't write words. Pictures are just easier to look at. Your tails are clearly going together, clearly going down. So this is the type of stuff we're going to piece together so that you can take a random equation like this and get a really good picture of what the graph would look like without punching in any numbers into your calculator. That's the goal of it, is what does your graph look like without actually doing any math. Last one, kind of putting it all together and writing our own equations. We are going to do a couple more after this, but the last one in your notes is the multiplicities can show up when you write your equation. So if you have a 0 at 4 with a multiplicity of 1, if you have a 0 at 4, what would its factor be? Yeah, x minus 4. Multiplicity of 1, meaning does it have an exponent? No, just done. If you have a 0 at 0, where does a 0 at 0 look like? It's just an x. You will always see x's just left in front. Yes, you could write x minus 0, but if you do x minus 0, does that minus 0 do anything? No. Multiplicity of 3 means what? Exponent of 3. What's the degree of this polynomial? 4. So it all is going to start fitting together. We are going to write equations for these polynomials. When you write an equation, write it in factored form unless you're told to write it in a different form. Factored form is our go-to for this. We're going to start with the one in the middle. When you start this, the key part is the zeros, because that's where you get your parentheses from. Start on the left side. Where's the first 0 on the left side? -2. If the 0 is at -2, what parenthesis did it come from? At that point, would you say it crosses through that point, bounces off of that point, or sways through? It just crosses. So if it just crosses, does it get an exponent? No. Where's our next 0 at? At 0. So where does that come from? It's crossing through again, so does it get an exponent on it? No. Where's our next 0? 3. So if it's a 3, where does it come from? What is it doing at that point? Crossing. Does it get an exponent then? No. What is the degree of this polynomial? 3. Does a degree of 3 match what our tails are doing? Yes, they're going in separate directions. Does that graph have a positive or a negative leading coefficient? Positive. You end up so it has a positive. So if you don't see anything in front, you assume it's positive. So you don't need to put anything there. Here is our polynomial. That one's pretty basic because they're all just exponents of 1. Can you hold it for like 5 minutes? Okay. Yes.
Doing the opposite of that. Starts with positive.
Depends on what your tails are. I would say just do that at the very end, like that's the last thing you do. Okay, now doing the one on the left. Where is the first 0 at? -4. So if it's -4, what is it in parentheses? +4. Is it bounce, crossing, or swaying through that point? Crossing. So does it get an exponent? No. All right, next one. Where does it touch the x-axis the next time? -1. So anytime it touches the x-axis, it's a 0. If it's -1, what is it in parentheses? No. X plus 1. At this point, is it bouncing, crossing, or swaying? Bouncing. So that's what a bounce looks like. It hits it, comes back up. So if it bounces, what is its exponent? It's a squared. It's a 2. Where's the next time it hits the x-axis? +2. So if it's at a +2, what is it as a factor? -2. Bounce, cross, or sway? Cross. So does it get an exponent? No. Last one. 4. So then it's x minus 4. Does it get an exponent? No, it's crossing. What's the degree of this? 1 plus 2 plus 1 plus 1 is 5. Does 5 match our tails? Yes. Do we have a positive or a negative leading coefficient? Positive. It's ending up, so it has a positive leading coefficient. Last one. Where's our first 0 at? I know it's this one got kind of faded. Is 0 at -6? So if it's at -6, what is it in parentheses? Levy, how do you know it's squared? Perfect. The balance tells you what its exponent is. Where's the next one at? -3. So when you have something like that, just put it in the middle. So if it's at -3 in parentheses, x plus 3, and then this is a sway. So that's what the sway looks like. It's like an S shape in the graph. So S for sway. So if it sways, what exponent? 3. Where's the next one? Bounce, cross, or sway?
Cross.
No exponent. Next one. So it could say 2. Last one. So you just go piece by piece, add up your exponents. So what is the degree of this polynomial? 10. Does a degree of 10 match what our tails are doing? Yeah, they're together, but which way are they going? Down, so what do we need in front? So if you have a negative coefficient, just put a negative number in front. We're going to do 1 or 2 full examples of this is what you should look like. This is what you should do every time you're asked to sketch a polynomial. So we're going to sketch that polynomial. Maddie, you know, at any point if you need to leave, you can just leave, right? Okay. So P of x just means it's a polynomial. It's the same as f of x. It's the same as y. Doesn't matter what that is. When you do this, always go in this order. Always answer these questions in this order, and you'll be fine. First thing, always the degree. Find the degree. The degree is a huge piece of information. What is the degree of this polynomial? 3. You have 3 pieces. Next thing, do the leading coefficient. I will never again write out leading coefficient. I will write LC, stands for leading coefficient. Do we have a positive or a negative in front? Positive. Those two together give you your end behavior. So if it's a degree of 3, what are the tails doing? They're going opposite. Since it's positive, where does it end? Up. So if it has to end up, where does it have to start? So just draw some sort of squiggle that goes from bottom to top. after that, list your terms. If your degree is 3, at most, how many terms could it take? 2. Or 0. So you take away 1, and then you just take away 2. The last thing you write down are your zeros. X in front, what 0 does it have? Bounce, cross, or sway? Cross. It's exponent is a 1, so it will cross there. Your next 0 is where? 2. At that point, is it going to bounce, cross, or sway? Cross, because it's the exponent on the outside, never the number on the inside. So an exponent of 1 means cross. Where's your last one at? -4. What is it going to do there? Cross. You are sketching, not graphing. So when you make your sketch, the only place that needs to have tick marks is the x-axis. So start by just tick marking your x-axis, putting down your zeros, because those ones you for sure know that's where it hits the x-axis. And then to make your sketch, look at your end behavior first. So where does this graph start? If you look at the end behavior, it starts low, down. And then once we hit -4, what are we going to do? We're going to cross through -4. The next time, we have to cross through 0. So somewhere between 0 and -4, what do we have to do? Turn around. And then we cross again. Where's the next place we're going to cross at? 2, which means between 0 and 2, what do we have to do? Turn around, and then we're done. Do we know how low this minimum goes? Do we know how high this maximum goes? No. How many turns does this take? Is that one of your options? Go back and circle it. The last final check is making sure your turns match up, because if your turns don't match up, you messed up somewhere.
Why even is it?
Because it's always take away 1 and then take away 2. Because it could be 2 or 0 turns. What we're going to do tomorrow is we're going to do, we're still going to do one more graph like this, but you guys will have half the time to just work on your assignment, and then I am going to go start graphing with you. I'm not here on Friday. So rather than have you guys go through 3 things in a video, I'm going to do the hard one tomorrow with you, so then Friday you just have the 2 easier ones. So the only thing we're going to add on is a graph. The difference between a sketch and a graph is a graph has more information. So once we have our sketch, we're just going to plug in numbers to see how high that goes and how low that goes. That's the only difference. We're going to do one more. This is the last one we're going to do today. So we're going to sketch that polynomial. Yes. What is its degree? 6. Agree. Leading coefficient. Do you have a positive or a negative in front? Positive. If you see nothing, assume it's a positive. Those two together give you your end behavior. So a degree of 6 means our tails are together or separate. Together. Positive means they go up. The turns. If you have a degree of 6, at most, how many turns can it take? 5 or 1. So you take away 1, and then you just keep taking away 2. Lastly is the zeros. Where is our first 0 at? -3. Since it has an exponent of 3, is it going to bounce, cross, or sway? Sway. Next one, where is it at? 2, and we will bounce. Last one, and we will cross. When you make your sketch, where do the tick marks go? X-axis. Put your zeros down. And then when you make your graph, be careful. You graph from left to right, but are your zeros listed from left to right? No, so make sure you know what number you're at. When you start your graph, where do we start? Up. So you start above, and then when you hit -5, what are you going to do? Cross. -5 is the cross. So make sure you look at the number. Turn around. When you hit -3, what are you going to do? Sway. Swaying is the hardest thing to draw down. So just show me that it like makes a little whoop right there. And then at 2, what do we do? Does that match our end behavior? How many turns does this take? 3. A sway is not a turn. So there's 1. That's still going up. So there's 2. There's 3. Go back and circle. If your number isn't on there, you're wrong. So pick something. So no homework tonight. You guys still have 5 minutes. So in those 5 minutes, if you could put the materials away, check the floor,